We are looking at solving the differential equation dy over dx is equal to the square root of yx. And what's different about this particular equation is we are also given an initial condition. So that says that when we plug in y into our function, we get 2 out of it. And this is going to allow us to solve for the constant that we normally have coming out of the solution of a differential equation. So we're going to start, however, with the first part. We're going to solve this initially for y, and then we're going to figure out what that constant should be. Now, normally, the first thing we do is we switch our y prime with the dy dx. That's already been done for us, so we don't need to do that step. Next thing that we're going to do is we are going to separate our x's and our y's. So let's start by moving our dx over to the right-hand side of our equation. This is going to give us a dy is equal to yx, and I'm going to, instead of writing square root, I'm going to write it to the 1/2 dx. A lot of times we want to switch over to a fraction as an exponent because it allows us a little bit more leeway when we're working with things. In particular, we can see that with yx to the 1/2, we can just distribute that. So we're distributing it to our x and our y. And now we get dy is equal to y to the 1/2, x to the 1/2. And the next thing to do would be to separate our equation completely. So we want to bring that y to the 1/2 to the left-hand side. In other words, what we want to do is we want to divide out by y to the 1/2. One last thing that we're going to do before we integrate is we're going to notice right here we have 1 over something. And when we have, I'm going to do this off to the side, 1 over a to the x, this is the same thing as a to the negative x. So in other words, our exponents turn into negative signs when we pop them up top. So in this case, we're going to rewrite this as y to the negative 1/2 dy is equal to x to the 1/2 dx. Now our equation is completely separated. We've got y's on the left-hand side, x's on the right-hand side, which means we can integrate both sides. We are going to add 1 to our exponent and divide by our new exponent. And we're going to do that on both sides. 3/2, 3/2. And we are going to add on a plus c. So we always want to have that constant on the back side. You only need one constant when you are doing a differential equation like this. Now, we're going to do a couple more things here to make this a little bit cleaner. First of all, that 1/2, right? If we have a fraction in the denominator, a over b, this is the same thing as flipping that fraction and putting it in the numerator. So we can kind of get rid of that fraction in the denominator by just flipping it around. So that gives us on the left-hand side of our equation 2 times y to the 1/2. And on the right-hand side of our equation, we end up with 2/3 x to the 3/2 plus c. Next up, what we're going to do is we want to get that 2 out of the left-hand side because we want to isolate y. We want to solve for y. So we're going to divide both sides by 2 on both our left and right-hand side. So this is going to give us y to the 1/2 is equal to, and I'm just going to divide both terms by 1/2, or multiply by 1/2, I should say, plus 1/2 c. And we'll notice that our 2's are going to cancel here. So we get y to the 1/2 is equal to 1/3 x to the 3/2 plus 1/2 c. Now, I don't really relish the idea of writing 1/2 c all the time. So instead of writing 1/2 c, I'm going to rewrite that. I'm just going to call that C1, and we'll go from there. So we have y to the 1/2 is equal to 1/3 x to the 3/2 plus c1. We were given at this point an initial condition, which is going to allow us to solve for our constant. The fact that we replaced 1/2 c with c1 is not going to change anything. In this case, we're just going to solve for c1 instead. Our initial condition that we were given is that y of 1 is equal to 2. So this is what we are going to be using. And that says that when we plug in 1 for our x value, we are going to get 2 for our y value. So we are going to plug in 1 for x 3/2 plus c1. So we are going to rewrite this one more time. I'm going to change that 1/2 to a square root symbol. It's going to look a little bit nicer here. And we get 1/3 plus c1. And if we solve this, we get c1 is equal to root 2 minus 1/3. So that is our solution for c1. And we're going to go and we're going to replace that in the equation that we have up here. So we're just going to substitute that in where we saw our c1. This is going to leave us with the equation y to the 1/2 is equal to 1/3 x to the 3/2 plus root 2 minus 1/3. And I will do one last thing at this point, and that is going to be to square both sides. So if we square the left-hand side and the right-hand side, on the left-hand side, our 1/2 and our 2 are going to cancel out. And on the right-hand side, we will see 1/3 x to the 3/2 plus root 2 minus 1/3 quantity squared. And there is the exact solution to our differential equation. Thank you for listening.